So we are on section 5.2a. We spent 3 days taking a look at how to graph a function from vertex form, looking at the transformations, translations, shifting it left or right or up or down, the reflection if it opens up or down, and scale changes, multiplication by a scale factor. So we're going to start to look more at the standard form and the factored form and how to work with those types of quadratic functions as well. So this is a review. All of these vocab words you've seen before. Remember, you also have them on the PDF on my website, so don't feel like you have to write these down. Standard form is ax squared plus bx plus c. Factored form is when you have a binomial times a binomial. And then, as I said, we spent quite a bit of time looking at the vertex form. Domain, as a reminder, is our x values or our input. Question you can ask yourself to figure out the domain of any function is what values can you substitute for x? In the case of a quadratic function, the answer is all real numbers. The range is the y value or the output. What values do you get out of the function for y? And as we saw with the parabola, y is either greater than or equal to the minimum value if it opens up, and that's the y coordinate of the vertex, or y is less than or equal to the maximum value, or the y coordinate of the vertex, if the parabola opens down. This slide you haven't seen before. Again, you have this on the PDF, so don't feel like you have to write it down. You have access to everything on my website. We're going to be taking a look, first of all, at our axis of symmetry. Symmetry is when you can reflect a figure across an imaginary line and it matches itself. So when we think about the parabola, and we have this line that goes through the vertex of the parabola, if you flip it across that line, it will match itself. So that's symmetry. To find the equation for the axis of symmetry, it's x equals h. H is the x coordinate of the vertex. Let me jump back to the first slide real quick. So when we're looking at the equation in vertex form, remember, inside the asylum, it's not normal, but that gives us the horizontal shift, and it gives us the x coordinate of the vertex. So the h in the vertex form is the same h that we have for our equation for the axis of symmetry. So if we're given an equation in vertex form, we can immediately figure out what that axis of symmetry is. And it's a vertical line, so it's an x equals. This is the vertical line that we would draw on the graph across which the parabola would be reflected. To find the equation of the axis of symmetry, if it's factored form, if there are two x-intercepts, then you would find the midpoint of the two intercepts. If there's one x-intercept, factored form would look a little different. It would look like this, a binomial squared. That would give you one x-intercept, and that will be the x-coordinate of your vertex. If we have standard form, so now notice we've got some coefficients in front of some of our variables. A is the coefficient of x squared, B is the coefficient of x, and C is our constant. To find the equation for the axis of symmetry, we use the coefficient of x and the coefficient of x squared in this little formula right here. X equals negative b over 2a. And that will give us the x coordinate of the vertex as well as the axis of symmetry. And vertex form, we've already worked with quite a bit. There's just a reminder at the bottom there. Okay, so we're going to start to take a look at an example for the equation for the axis of symmetry. So notice on this graph, the information that we're given is the intercepts. So we've got x equals 1 right here, and x equals 7 right here. So the first step to find the equation for the axis of symmetry is to figure out which information you have. Is it a graph where you know the intercepts? Is it an equation in vertex form or standard form? In this case, as we noticed, we've got those two x-intercepts. So then we use whichever piece of information is important. So if we have standard form, we do x equals negative b over 2a. If we have the intercepts, we average the two x-intercepts. Well, that's the information we have this time, so we're going to find the average of 1 and 7. So the equation for the axis of symmetry would be 1 plus 7 all over 2. 1 plus 7 gives us 8. 8 divided by 2 gives us 4. So the equation for the axis of symmetry is x equals 4. We just did step 3. And then the last piece in this example is they are asking for the domain and range. So remember we talked about for a parabola, for a quadratic function, the domain is always all real numbers. And the range, what we have to do is figure out the y-coordinate of the vertex. We're going to have to estimate that from the graph on this one since we don't actually have the equation of our parabola. But if we look at this, when x is 4, y is about -4. The parabola opens up, so it would be y is greater than or equal to -4, the y-coordinate of our vertex.